Hey, welcome or welcome back if you've been here before. This video is going to be about designing front panels in EasyEDA. I've, yeah, quite soon after starting my first DIY build module, I wanted to start designing my own. Of course, it was quite easy to figure out a way to convert a schematic into a PCB layout, but then yeah, trying to do the front panel, I ran into some issues. I had very little clue about what to do. I actually went to a local metal shop to ask them about engraving and cutting a metal front panel. Yeah, this was super expensive. Then yeah, you start looking around. Um, what's available. Casotronics does these laser cut plywood panels, which look pretty cool, but wasn't the look that I'm after. And also, I don't have a laser cutter or any other yeah tool of that nature. So then I ended up with PCB front panels. Um, yeah, I know there's many different ways to do this. I think the best thing is use Illustrator, maybe Inkscape, and make a professional layout like that, and then convert that to PCBs. There are yeah a number of scripts on GitHub to convert your SVG to yeah, to a front panel PCB in a KiCad. Um, I don't know KiCad. I want to learn it, but uh, not at the moment. So I started doing it in EasyEDA, which is the same EDA software that I use to create the PCBs. Um, so yeah, let's get into this. Yeah, if this is something you're interested in. It's not going to be fast. It takes a while, and I'm pretty sure there is uh, a bunch of different approaches to this, but this is the one that I use. Um, yeah, already started out with a PCB. Maybe it's better to create a new one. Well, let's do a completely new project. Let's call this a demo panel. Save it. First, get uh, a schematic since we're not doing a PCB at the moment. Let's do a close this. Just start a new PCB. Get a pop-up window. Units. I work in millimeters. Others might use whatever. I think mil is another value. I don't know the exact conversion, but millimeters is fine for me because I live in the metric world. Two copper layers. It is a two-layer board. Don't, yeah, you can go multi-layer, but that's just making things unnecessarily expensive. A rectangular board outline you can do, yeah, round, custom. You could upload an SVG file and have a board that looks like a Christmas tree. This is a eurorack panel, so not interested in this. Start position of the cursor starts X and 0. I like to just start at 0 and 0. Doesn't matter, it's just my preference. Width, I know this is going to be a 6 HP module, so 30 millimeters. Height is 128.5, like so. And then apply, and um, there is a board outline. Yeah, so now we have a board outline. You make this a bit bigger. Um, I don't like to work on the full board because I want to prevent to drag or drop the width and mess things up. So typically what I do, I go and create another rectangle. So currently we are in the top layer. If you see, if I do something, it's going to be a red color, which is a top layer copper. Not doing that, going to the document layer, and then actually going back, creating that rectangle again. Or not. Doesn't really matter. This is, I want to set this the same width as the board. And for the height, taking 110 millimeters. This is my favorite height for PCBs because it is actually yeah, the maximum clearance between two eurorack rails in a, yeah, I just like to line this out on the line. There's no function. So this is a full white canvas. It has a fill. I'm going to remove that fill because I want to make some lines to align my panels or my holes and all the other stuff. Okay, so now yeah, the full size front panel. Um, uh, in purple, which is the board outline, and then a slightly smaller white square document on the document layer, on which is going to be my canvas to work with. Yeah, I think some important controls. If you want to measure 2 points, let's say from this corner to this corner, you can click N and then measure, and it will leave the line where it is. Yeah, you can go back. Of course, you can also go to, let me see, where is even the measure tool? See, I always use, that is stupid, I always use the short keys. Oh yeah, dimension is n. So clicking this will result into the same. It is a very professional, well prepared start to this video. Again, going back here or just hitting Ctrl Z as yeah, I typically do. If with the right cursor you can move the screen around. With the left cursor you can click things and then move that around. So grab this whole thing, move it around. Let's go back, Ctrl Z. You can also select an area. This will move everything. Oh, go back. You have to select a part of it and move everything that is selected around. Again, Ctrl Z to go back, or the little return here. So for this build, I actually not just going to do some random layout just for demonstration purposes. I promised Ale of Bartola Valves to yeah, to do a front panel on his Turing machine version, the Zeus machine. So that's what I'm going to use. Okay, so having the board over here, for me, it's I cannot see it, but for me it's on a screen to the right, so I'll be looking to the right more frequently. Yeah, so typically I start with some of the larger lines. So I think on eurorack, typically the holes are on the top and the bottom. Depending on the width of the panel, you'll have either one or two. I'll make sure to add a link to the Doepfer guide on the eurorack standards. I think for now I'll focus on the actual front panel and do all the fancy stuff later. Yeah, if you see on the measurements, this board is also 110. It's very common to use this. So I think, yeah, first I go and use some of the larger measurements. So I typically also do that with N. Oh, start at the corner here. Oh, this is not the full corner. So again, and are we in the document layer? Because these lines are going to remain visible. 5.9, there is a horizontal line. Like you see, the grid spacing is actually, I think, in a conversion from inches. So 5.9 is going to be either 5.8 and a bit, or 5.97. You can just use any distance. Actually, if you pull straight down or straight to the side, it's going to be a straight line. So now I have my first line on the board. Since this is in the document layer, it's not going to end up in the PCB. But yeah, now I have the wrong measurement, and if I'm going to place any holes along this line, it's going to be misaligned. So you can go just manually to the length. So 6.096, same as there. So I'm going to change this to 5.9. Yeah, it's seldom super critical, but yeah, for the intent of this video, let's do it as precise as possible. Yeah, what are some other major multi-use lines? I think from this 5.9, there is uh, the next measurement is relative to that, so that's 13.3. Now I don't like to build lines on lines because, yeah, as you see, there's always a snap. Does it really matter? No. Do I care about it? Yes. So I just take 5.9 and 13.3 is, so I'm not, that's 18, 19.2. Again, this is 21, doesn't matter. I go here. So that's 19.2. I will for sure, after stopping recording, recalculate some of this because it's going to be a nightmare if I end up with the wrong measurements in this. Yeah, so then let's see from the bottom. If we go look at the bottom potentiometers, these are 5.7 relative to the edge of the board. And yeah, you'll see me just taking everything of the one dimension that I can really trust, which is the length and the width of the board. Then there is a 11.4 from this. Again, I could measure from here. Don't want to do that. So 5.7 plus 11.4 is 17.1. It is going to be a demonstration of how well I can calculate in my head. Wait, 17.1. So this is already almost 17.1 there, and building up from that. So I'll open up a calculator window, not because it's going to be absolutely critical, but I don't want to bore anybody with my calculation. So 17.1, and then the next line is 10.8. Short-term memory error. Again, just dragging it to the side will result in a straight line up or down. If you want to measure diagonal, that's very possible. It's just yeah, then you need to drag it, but it's a bit more risky. But again, oh, the it will show you once you are aligned. Again, the next line is again that 17 point, what do we have? 70.1 plus 15.6. Let's go. Yeah, that's a bit. I'll leave it for now. I'll just do the right side of the PCB first. So the LED. This is the LED height or position. Then above that there is the switch, the right and clear. 27.9 plus 14.6, 42.5. And you might notice me going from left to right and right to left, alternating on putting these lines, is just to not overlap and overcrowd the sides. This is 42.5 again. Putting down the wrong measurements for speed and then correcting it later. Okay, 42.5, and then the 26 to the first LED, 68.5. I might have to speed some of this up in the edit because this won't be very exciting. 68.5. And then the spacing between the LEDs is always 5.2, and it should leave us with 4.8 left at the very top. Yeah, so this will go on for a bit more. Typically, once I have the X and Y axis marked like this, I just take a little circle with the full circle tool. You can also do it like this. Just make a circle. You can also just hit the short key and do a circle like this. This is a bit big. Typically 3mm LEDs are used. Yeah, the width of the circle doesn't need to be this big. I'll just leave the standard definition there. So the radius is 4.4. So to get a a 3 millimeter LED. I usually use a bit of clearance. I use a 3.2 millimeter hole. So that means a 1.6 millimeter radius. Nice tiny circle. Let me use this. Let's make this a pot sized. So let's take it 7. Oh, no, of course not 7. 3.5. Oh, and I'll park this over there. Typically what I do, I create the one, Control C, Control V, and then align that as good or bad as possible with the X and Y coordinates. Again, this is a very small grid size. So if it's left or right to this, yeah, it's not gonna bother anyone, and for sure not an LED. Yeah, now we can let's see if we can use this, because it's going to be a bit of a pain to go all the way from the bottom. So let's try how how we can do this. Let's see, this is again wrong dimension, 5.2, and then you can also copy a measurement like this. Again, Control C, or just here at the top there is a copy and paste button. So I'm taking this reference point, so because if I paste now, that's where my cursor is going to be, and now I'm lining that up as perfect as possible with the other line. And again, the Turing machine has 8 LEDs, so I will repeat this task 8 times. 7 actually, because the first one is already in there. Yeah, if you have a better way of doing this, please do let me know. So this is 1, 2, 3, 4, 5, 6, 7, 8. I told you or warned you, there's going to be a lot of me counting. So that should leave us with 4.8 millimeters. Getting to 5. So most likely that is an issue with the spacing on this. So the lines probably shouldn't be on top of each other, but next to each other. So let me try to do that. Oh wait, the bottom one is slightly offset, and then now it all goes to hell. Again, are there better ways to do this? For sure, but this is my way. Okay, so 4.95. Yeah, I'm not gonna be bothered with this. This is 0.1 millimeter. Close enough in my book. Okay, again, copying all this, all these holes. But feel free to draw a new one every time if you feel that's the way. Okay, so that's the LED section done. Let's go back to some of the other stuff. Actually, these holes, you can also just make them bigger if um, I copy this hole and put it, let's say over here, for example, and later I want my actual hole to be aligned, then you can also select the center and then it snaps into place. We're going to do this exercise later. Okay, the other measurements relative to the from the bottom are so this 15 or 17.1 line. From that they have a 15.6. Let's go all the way back. 17.1 plus 15.6, 32.7. This is a bit busy this side, so I'll get this. So yeah, some of the measurements will overlap. You can always drag it to the outside because it's basically the same. Oh, again, selected length 32.7. 32.7 plus 21.9, 54.6. Very consistent with my points or dots. No, in English it is a dot. In Dutch it's called point. And oh, this was a pretty good 56.61. I'll do this precise just because we can. And 21 is 75.6. I don't need a calculator for that. Again, and yeah, I'll put the most important hotkeys in the video description because yeah, I don't feel like going with my mouse everywhere. And we said 75.6. Okay. 21. Now we still need to go to the next one, 75.6 and 22.7 is 98.3. And again, snap into that corner. And actual length doesn't really matter. Oops, length 98.3. And then what do we have left at the bottom? There are 4 in and out jacks. Yeah, what is important on those is the center point, because this is where the hole for the yeah, through the panel is going to be. So that's a very critical dimension. So that's 6.8, and then relative to that 14.6 going to the next one. I'll start here. I'm not starting on the bottom, otherwise if I do that I can show. I do the measurement like this, and I want to have this crossing line. I'm getting my dimension here. Doesn't matter, nobody's going to see it, but I rather start from that actual line and work down and have all my dimensions on the outside, and only the stuff that I care about on the inside. Again, 6.8, not 9 but 8. I go back to 6.8 plus 14.6, 21.4. Again, starting from the same starting point and more or less here. Oops, 21.4. Double check. Okay, so these are all of the dimensions. Okay, now we can start creating yeah, the actual layout for all of the holes. Actually going to create a new circle. I'll just do a bigger one and snap things into place. It's a bit big. That's, well, doesn't really matter. 10 millimeter hole. Center. So at the top here we'll have a potentiometer. There is that 8-step switch, rotating switch. Get those from Thonk. I think they're definitely the yeah, the cheapest source on those, especially if you order lower quantities. I think yeah, if you use multiple, they might be cheaper at tme.eu or Mauser, but for sure for a single item, Thonk is the best option. Okay, write and clear switch. Then we have another pot. See, this is a pretty busy board compared to uh, the original Turing machine, which is very spacious, very wide. Actually did a panel for that in the past. Let me show you maybe what that looks like. Oh, loading. This is my original Turing machine panel. Thanks Tom Whitwell for making that open source, but that's not why we're here. Going back to what we were doing. Again, I forgot if I still have this selected. Snap this whole. Okay, so the potentiometer is not on this line. It is, or the jack socket is on this line, and the jack socket is on the 21.4 line, and then there is one at the bottom, and there is another one at the bottom. Yeah, so that's the layout. These are the measurements. Let me hit save on this. Close this. Let me hit save on this panel. You can either do this little floppy disk. Of course, Control S will also work. Yeah, EasyEDA is a online software. It runs very well in the browser, but yeah, so make sure that that you're connected to the internet if you're saving. Okay, so now if we look at what we have here at the top, there is a 3D view. What do you see in the middle of the screen? There is a full panel, no holes, no nothing. And then the other part is completely invisible. Let's go back to this. Okay, so now we need to start making some actual holes. Yeah, you can use the circle tool again. There are a number of ways to do this. So you can make a circle in the panel. Let's use well, let's do it in the actual panel. And then this is a circle. Again, it's a document label. It won't be visible if I were to change this to a let's call it a board outline. It gets a different color, and you'll see later what happens. And then we have a actual hole tool here. Now you place a hole, this very tiny hole, diameter. So yeah, be careful if you're creating a circle. This is the dimension is radius. So if you want a 5 millimeter hole, you need a 2.5 radius. Let's put this here. And if you want a 5 millimeter hole with the hole tool, you go here, it is diameter, so you type 5, and these two are the same. Let's see, convert this to a board outline. And now let's see what happens in the 3D viewer. Oh, yeah, the board outline tool looks a little funky in yeah, in the real world or in the finished PCB. This will actually just be a hole like this is. This is a problem in the rendering of these 3D models, but believe me, it will work. Okay, so let's delete those. Okay, so now we are in business on these holes. Again, this is a 3 millimeter LED. So let's make that a 3.2 millimeter hole. I have used 3.1 before, and then yeah, it had some clearance issues due to burrs, mainly in aluminum panels, aluminum for the Americans. Again, making life easy, just copying, so Control C, or using the copy, whoa, not paste, copy image, and I just go, okay, again, if you're copying, Control C, select that reference point in the center, because we want to align this with the rest of what's going on here. And it is pretty smart, so it will recognize the center of the circle. That's why I use these circles in the demo. So, whoop, going here, here, and here. Snap in place. I forgot what the width was of a hole. It's been a while. Okay, so this is a 7. Oh, this is a plated hole. Okay, 7.1 for alpha pods, and it is a 9.1 9.1 millimeter for drill for the switch. Again, you yeah, if you work with the data sheets, you can yeah, you can figure out all these diameters in the data sheets. I'm lazy. I just copy my existing work. Okay, so let's go with another hole. This is a 7.1, oh, not 71, 7.1 millimeter hole. It's going to be used for all my pots. Hey, this top thing looks misaligned. Let's go and fix that immediately. I made a mistake there. One pot, another potentiometer. All these holes seem to be off center. So what's going on? I think I made a mistake with copying. Oh. It's easy to correct just with when it's selected. You can just use the arrow keys to move it around. It's sometimes a bit easier than dragging it with the mouse. Okay, looks good. Let me hit that save before I make a mess again. This is not the right hole. Okay, never mind. Just no time for dirty jokes. Oh, don't need to copy again. Actually, can paste multiple times. I'll just use one of these and copy that into place here, knowing that this will be, and we looked at that before, Turing machine 9.1. The reason why that's 9.4 is these are plated holes, so they need a slightly bigger diameter. So 9.1 for the rotating switch. Let me go and copy this into place. Oh, copy and snap to the center, and to the center of this, center of this one. Oop. And center of this. Okay. Again, these are all too big. Eurorack 6 millimeter. Yeah, 6 millimeters is really cutting it. So let's make those 6.1 like we made the other ones. Then there is sufficient clearing at all times. Then we have another LED for the clock. Let's grab this nice LED hole. Snap that into place, and another hole for the switch. Again, make sure that you check the oh, these are misaligned again. Move this up. I don't know why, but it feels like my my thing moved here. The Turing machine switch, big daily well switch, 7 millimeters. Okay, well, let's leave that at 7.1. Yeah, and that's at least the mechanical part of this. Yeah, you always have to accommodate for yeah, for the knobs. So yeah, you have to make space for that once you go into labeling what you're doing. But yeah, let's add some text. You want a label. Of course, this is going to be invisible. Well, let's do the text at the other side. So typically what I do now, because now it's all next to the board. Again, if you look at the view, empty board, nothing there. What I do is I take the outline of this, copy it, use this reference point, and then paste it onto the panel. Yeah, it's not clearly aligned. Doesn't matter. You can select this one and you can select this one, and let's see. You can align these items. Format. You can align horizontal centers. I typically use Control Alt H, and then also align vertical centers. Oh, and again, format, align vertical centers, align horizontal centers. So now this is in the middle of the panel. So now we have to select all of this, because I want to move this. Yeah, you could drag and drop. That you might run into issues. So I rather just copy this whole thing. I select this here corner and then paste it inside of the actual PCB. Align. You can zoom in and do that very clearly. So now we have this double. Let me move this out of the way because oh, boom, select it all and drag it to the side. And if we look at the PCB now, this looks like a PCB with some holes in it. Again, if you want to use, let's see, again, 3 millimeters from the top or bottom edge. This is more or less 3, and then from the side, it is 7.5 millimeters, which is quite critical to get that right. All my first PCBs didn't fit in eurorack rails because instead of the 7.5, I used the 5.08, which is the actual grid size, but the first hole is 7.5 millimeters from the side. Yeah, not super critical because I usually use slotted holes, but let's get super critical for the people that use round holes. Yeah, spacing 3 millimeters from top and bottom. This is getting a bit too awkward. Typically I do this first and then have all of this removed. So this is 3.1. We want this at 3. And then do the same at the top. And or clicking this measurement tool again. So it's going straight down. And again, 3. Oh. So now if I place a hole for an M3 screw. That would typically be a 3 mm hole, so I'll just reuse the hole for the LED for practicality, and one here at the super busy bottom. So with a 3.2 mm hole, this should be fine. This is getting a bit messy. If you want to select or unselect the view here, then you see what the board is like. I actually like to use these lines. So depending on the pot, the potentiometer and knob you're going to use, you need to account for that in the clearance of any labeling. Okay, so let's do the labeling on the top silk layer. That's a layer on the PCB that's let's say indicates what kind of component goes where. So yeah, now this says text. Let's call text, you know, knob 1. Again, you can do everything you like with this. So let's pretend this is going to be a Davies 1900H clone knob. These are going to be about 12 millimeters in width. So yeah, if I put it here and then do a well, let's layer doesn't really matter. Let's use a red one to indicate what's going on. So I do a 12, so 6. So let's do a on a 13, so 6.5. Do Davies knob here. You see this text is going to be obscured by the knob itself. Yeah, which is annoying because you can't read what it says. So let's convert this to a document layer, and let's just use this to indicate how far off it needs to be. Yeah, so if you look at this, well, let's look at it in do the 3D viewers. There are too many of them open. Use the 3D viewer. You can see this is now offset from the hole. That doesn't look good. Yeah, you can align this again like all of the other stuff. You select the text, and then you want to align it to, let's say, the hole, and then you hit format, align vertical centers, and boom, there you have it. They're aligned, but the hole moved. That's not nice. So what I typically do, I use these white document lines as a reference. Click those first and then align to them. You saw there was still some movement here. So typically it's better to just try to eyeball the center and then go align. Oh, it is okay. I just used the outer one. So now that I have this, it's maybe not the line width. I'll just do 0.3. This is a front panel, can be a bit bold, maybe a bit bigger. So again, it's now misaligned. Eyeball, and then do it like so. Yeah, if I'm happy on the 3D model, yeah, this is what it's going to be. So knob 1, good enough. So I can again copy this and then paste it to the second one and the third pot, and looking at what we can do. So this is getting a bit close to each other. For my liking, I might do that differently later. Yeah, for the switch, you also need to keep some clearance. Let's copy this again to here. But of course, a tiny switch isn't going to have a 8 or a 12 millimeter knob on it. So I think for a switch that's about 8 or 9 millimeters, these are the bigger daily well knobs. So let's count on yeah, on 10. Then we have some clearance. So now this is a bit further. Just go down here. Since this is a switch that has a write and a clear, I'm going to copy this and just put it down here. Go clear, write, and see, is this going to move? No, and then this. So clear and write. Yeah, see above the eye, I have a bit more space on this side. This is called change. I wonder what this is called on the Turing machine. Yeah, so I did this definitely an adaptation, not just a 6 HP clone. Change length. Oh. Yeah, let's maybe go with caps here. Change. We can work that out later. Scale. Oh, scale has an E. And then there is a off. Oh. I am an idiot. Offset. These are the main controls. Then there is a little clock LED here. I think I want these to be a little smaller. 0.254 and 2. And then copy this guy over here. Oh. Again, select the right position. I need to realign this because we have a different font height and width. Then this clear. I'll align this as well. Control Shift E is the vertical one. Then there are the in and outs. A Tonkicon jack socket will have either a 6 millimeter six-sided nut or a knurled nut. So let's clear um, at least 9 uh, yeah, millimeter for the nut because we don't want to go over it. So yeah, let's rather make it 10. So radius of 5. Okay, this is already that. So let's use this. Copy, paste. Oh, let me here. CV. This is clock. Okay, for some reason this is already aligned. Yeah, so actually both, yeah, we'll see how that looks later. Noise, that's yeah, that's a bit tight. That's noise and CV out. Okay, let's call this then a CV in because we have a CV out as well. Yep, not good. Again, eyeball the position, align, Control Shift E, or the align tool in format. Boom. Still too far out. It has some quirks. So if we do this now, we have all the labeling. I already know from looking at this that this label is going to be covered by yeah, by the nuts. So yeah, this is a little bit cramped to do it in this way. So yeah, one option is to go above and below. So you can also align these, align horizontal centers. So that's going to be looking clean like that. And since it's not going to fit on the top, we might have to just move it to the bottom. Yeah. Boom. Align it again, Control Shift E. So now let's look at this. Let's give it a nice header. I will connect it to the band image. Called it my module. Put that here. Add a well, let's put that at the bottom. And then let's look at what this looks like. Not too bad. So it looks like a front panel. It's not too exciting as it is. It has the labeling. It has a name. You Yeah, you can fancify this however way you like. You could add a little picture to it, select an image file. Whoop, not uh, panels. So I made a little light bulb. So it is not going to be any kind of high definition graphics. Yeah, so big contrast really helps. Yeah, there are yeah, third-party apps to make the importing a bit better on SVG files. So this looks pretty clean. We have a nice light bulb. It's 34 millimeters is too high. I think we have about, let's say, 12 at the top. Oh, okay, so the height. So let's use 15. See if we can jam this in here. No, that's going to be too big, unfortunately. Well, let's place it here. It's more about the principle. Um, okay, now again, going to demo view. Now we have a module, holes. We have an image on there. We have a name. Pretty good. There's a backside. The backside doesn't have anything at the moment. If you go to the PCB, so actually I want this light bulb, which is my new amazing logo. I actually want this to be visible on the backside. Let's move that to the bottom silk layer. Let's add some text to the backside. I'm going to now remove these document labels to make it less annoying. Add text. We are still on the top layer to the bottom. Yes. Whoop. Let's call that hashtag my modular journey. Boom. I'll add it like this, or maybe I want to rotate it like this. In that case, I want it to be bigger because bigger is better. Let's do it over here. Maybe align it with the vertical X or the horizontally in the center of the board, like this. And well, that was actually a good position. Okay, now let's look at this panel. And front side, no change. Back side, no change. So this is what the panel looks like. That's you know, pretty decent front panel already. Yeah. So I guess I'm done with this. Let me open the document again. Typically, I save my working document, then I'll go and do a clone, then do a demo panel version 0.1, and then I'll work off this. Okay, I will close this, go to this one, and then remove any unnecessary stuff that is on here that I don't want to see anymore if I continue with this panel, because I have my measurements. I know what to do, I just select all the document on the document layer. Um, I'll leave these lines here, or I can just select them manually. Again, they're not in my way, just this dimension, and then I am ready to go. On that note, I am also ready to go. I'll save this. Um, yeah, thanks so much for watching. If you're here all the way until the end, yeah, I guess do all the like, subscribe, whatever stuff on YouTube. I'm not monetized. I'm not ever going to be monetized probably, but it's more, yeah, I like to connect. Yeah, if you have any questions or you want to, connect differently, yeah, pretty regularly on Instagram, where, yeah, you can see the end results of my build. So, hey, thanks so much for watching, and next time I'll show how to make this panel a bit more fancy than it is right now. Thanks. See you next time. Bye bye.